Hello, good day viewers. Into this tutorial, I will introduce the permutation and combination to you. So I realized there is a topic, the permutation. So I can't explain only permutation, but it has a brother which is combination, permutation and combination. So the first thing that you have to understand, what is permutation and what is what? What is combination? So permutation, it is what? Arranging in order. But why combination? It means what? Combining or selection. So the main basic idea in this is that to know the difference between the two, you have to know that in permutation, orders what? Orders matter. But why in combination the orders doesn't matter? It doesn't matter. What I mean is that in permutation you have to keep them in what? Arranging in orders. But why in combination it doesn't realize either they are in order or not? So first I'm given what? I have A, B, C. So what will be the combination? The combination will now be C, A, V. So this is combination. So as you can see, in permutation they are arranged in order, but the order, it doesn't matter. So suppose I have A, B, C and D. So what will be the permutation and combination of this? So in permutation I'll have A, B, I'll have what? A, C, I'll have AD, and therefore I'll have BA, I'll have VC, I'll have VD, and therefore I'll have CA, I'll have CB, I'll have CD, and also I'll have what? DA, DB, and what? And DC. So what will be the permutation of this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the permutation of this will now be 12. So what will be the combination? So in combination, let's say I have AV. So therefore I will get away of this, because in combination orders doesn't matter. I have AB, I have BA, so therefore I will not use this, I'll only use this. So what of AC? In AC I have CE, so therefore I will get away of this. What of AD? In AD I have DA, so I'll get away of this, I'll use this. So therefore I have VC, I have CD, so I will get away of this, I'll use this. So I have BD, so I have BD, but again I know I have DB, so I'll get away of this, I'll use this. Also I have CD, and therefore I have DC, so I'll get away of this, I'll use of this. The rest I'm left with 1, 2, 3, 4, 5, 6. So combination should now be 6. So I have you get this. So there are equation, there are formula for combination and what? For combination and permutation. The permutation of P and R, it is equals to n factorial over n minus what? N minus R factorial. But why combination of this should now be n factorial divided by n minus R factorial into R factorial. So as you can see, combination is the same thing as the complete permutation multiplied by what? Multiplied by R factorial. Wherever you are just going to multiply what? Multiplied 1 over R. So therefore multiplied by what? Multiplied by 1 over what? 1 over R factorial. So combination is the same thing as permutation multiplied by what? By 1 over what? R factorial. So this should now be equals to, at the end you will have what? The permutation, which is n factorial, divided by what? N minus r factorial, multiplied by the 1 over what? R factorial. So this should now be n factorial divided by what? N minus r factorial, multiplied by this what? By this r factorial. So let's see whether I have some examples to do. So first, the first question says that find the number of what? The number of ways of arranging. So you have to take notes of this arranging. Arranging, it means permutation, while combining or selection, it means what? We are comparing to combination. So of arranging 3 women in 5 sets, so you have to take a look that the n shall now be what? 5. YR, it is what? It is 3. So permutation n of p of r should now be equals to what? N factorial divided by n minus what? R factorial. This should now be equals to 5. N, which is 5 factorial, divided by what? N, which is 5 minus r, which is 3, all factorial, should now be equals to 5 factorial. 5 minus 3, which is what? 2 factorial. This is the same thing as saying 5 multiplied by 4 times 3 times 2 factorial, divided by what? 2 factorial. This will cancel this. This should now be 5 multiplied by 4, which is 20. 20 multiplied by what? 3. This should now be what? This should now be 3 times 0, 0, 3 times 2, which is what? 6. So this shall now be equals to 60 what? 60 ways. So the next question says that, but if you are referring to combination, n of combination r n factorial over what? N minus r factorial into r factorial. So this shall now be 5 factorial divided by the value of what? Which is 2, because 5 minus 2, which is what? 5 minus 3, which is 2 factorial, and I have the value of r, which is what? 3 factorial. So I have to say 5 times 4 times what? 3 factorial, all divided by what? 2 factorial, 3 factorial. I simplify this because I have 3 factorial here, because this will go with this. So therefore I have what? I have 20. 5 times 4, which is 20, divided by what? Divided by the value of 2 factorial, which is the same thing as 2. So this should now be 10. So this is combination and what? And permutation. The next question says that how many distinct arrangements can be made from the word statistic? So this is permutation what? Arrangement. This is an arrangement. So we have to first find the n and what? And r. So how many n we have here? How many r? We have only one n. We have to count the complete words called statistics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10. What of r? How many distinct arrangement can be? So this is what? Repetition. Value of r, we have to see how many words repeat themselves. S comes once, and therefore t appears what? Twice. Statistics. So the next thing that I have to say r1. The word s appears 3 times, which is what? S appears 3 times. R2, which is repetition. R2, which is T, appears 1, 2, 3, also 3 times, which is T. What next? I appears 2 times. I would say R3, which is what? 2 times. So therefore, which is I. So I have to say that the n of r, which is permutation, it will now be n factorial divided by r1 factorial, r2 factorial, r3 factorial. This should now be equals to, which is 10 factorial divided by what? R factorial, which is what? R1, which is 3 factorial, R2 3 factorial, and the 2 factorial. So this should now be equals to 10 factorial over what? 3 factorial, 3 factorial, 2 factorial. This is the same thing as writing 10 times what? 10 times 9 times 8 times 7. Okay, let me just first say what is 10 factorial. This and this. As we all know, in the introduction to factorial, we know how to multiply this. So 3 factorial, which is 6. 6 multiplied by 6, which is 12. 12 multiplied by 2, which is 24. So therefore 6 times 6 times what? 2, which is what? Okay, sorry. 3 factorial, 3 times 2, which is 6. Yes, and then 6 multiplied by, let's say, 3 times 2 times 1. 3 times 2 times 1. And then 2 times 1. This will give me 6. This will give me 6. This times 6, it will give me what? 36. And 36 multiplied by what? By 2, which is 72. Which is 10 factorial. Or let me say this shall now be 10 times 9 times what? Times 8 times 7 times 6 times 5 times 4 times 2 times 1. So this it is equals to divide by the value of 72. 10 factorial divide by 72. Let's give it 10 factorial divide by what? 32. So this should now be 50400 what? How many distinct arrangement can be made from this? So these are the arrangement that can be made from what? From this. So this is all I have for you for the permutation and combinations. So as you can see, it is not much harder, it is very easy, but you have to take note of this repetition. This is permutation by repetition, because you might be asked for a question that whereby letters will repeat themselves or numbers will repeat. So therefore you are just going to count which letters or word repeats themselves, and then you are going to pick out the numbers. If they appears 3 times, you have to pick 1, 2, 3. If they appears 4 times, you have to pick 1, 2, 3, 4. So this is all I have for you. Don't forget to subscribe to this YouTube channel. Thanks you for watching.